that's why we are so focused on generating this database of 3D maps, because really those are the enabler of what in general we call spatial computing, physical AI, or machine perception. Without this data, it's basically impossible for most of the use cases to relocate in space.
Thanks, Diego, for coming and joining us to talk about Over today. It's been awesome getting to know you guys over the past couple of months, as I've been, as Connor knows, like getting very much obsessed with VR and AR and the world of sort of like spatial computing. And you guys are one of the projects that are flying extremely under the radar, but you have some of like one of the most fulsome platforms. I've used pretty much every part of your developer platform by now, and it's been fun getting to know y'all and invest in y'all. So glad to have you on. And I guess to start, it would be awesome if you could tell us a bit about yourself and what is Over, and just a quick high-level overview.
Yeah, that's great. Great plan. So yeah, thanks for having me. Super excited to be here. So my name is Diego di Tomasso. I'm co-founder and CEO of Over the Reality. Basically, we founded this company together with my partner, Davide Cupini, that is the CEO, back in 2018. And basically, we went live in 2020, end of 2020, I would say. Yeah, I mean, I've been in crypto since 2014 when we read the Bitcoin white paper, but basically 2018, I went full into this project and basically built to be able to be live after 2 years, basically. And yeah, regarding what is Over, the way I would describe it right now is a deep in spatial computing platform with a very ambitious goal. And our goal is to create the most extensive 3D map of relevant locations in the world. And I would say that right now, this objective is going quite good because we just smashed the 100,000 3D maps milestone. And just to give an idea on how much data we generated there, so it's more than 50 million pictures. It's 55 terabytes of data. And basically, we have 40 GPUs that have been crunching this data during the last year to actually turn these pictures in 3D maps. So it's really massive. And in terms of also comparison with other companies doing that, I mean, right now there are a few companies that are doing this in Web3, but still at a much slower scale. If we need to find some comparison, we need to go in Web2. And in Web2, we have Niantic that is collecting similar data. And just to give you an idea of the numbers, they declare 1 million. Actually, if you go in their websites, there are actually 300,000 in total, and 170,000 are available, are actually usable. So it's kind of depends on what number you look. It's either 60% or 30%. But anyway, a very relevant number also compared to them. And this is not the only thing we do. Of course, we have this main objective, but we don't only collect data for the sake of collecting those. Of course, we turn them in 3D maps, but we use these 3D maps for downstream tasks. And the most developed, the most important that we have at the moment is an end-to-end solution to publish geolocalized AR content. So basically, we provide the tools to publish, both a web builder and a Unity SDK, and then also the tools to visualize this content through smartphones, smart glasses, and VR devices. And up to now, we have more than 22,000 content experiences that have been uploaded and geolocalized by our community. That's it in a nutshell, I would say.
But Niantic's the Pokemon Go developer, right?
Exactly, yeah. In fact, the maps they generate actually, I mean, it's not totally clear, but I mean, it looks like most of their maps are generated from the pictures that are taken from Pokemon Go players. And also, this is an interesting angle because of the quality of the 3D maps that are generated. In our case, we use this token incentive model to actually generate the maps. So if you don't get to a specific quality level, we are not going to pay you. So we can force the collection to have a sort kind of a minimal quality. Well, in their case, of course, they take everything because there is no specific incentive to create quality maps.
For sure. I was just pulling up on my phone, guys, in case people haven't done a 3D map. Like, here's a little decoration that came with my apartment that I took using an app called Polycam. Diego, I don't know if you can describe like what's it for people that haven't done it or haven't used the Over app, or how do you map a location and on a user perspective, and then also like what do you guys do on the back end to turn what are a bunch of videos and images into a 3D map?
Yeah, basically the way it works is that obviously through our app, we have you just click map and your guided interface. You have a UI that basically helps you to map the location. What happens is that basically the experience is like taking a video, but with some UI that guides you on the way to map. And basically you take this video on our area. Our target areas are 300 square meters. And the activity takes around 2 to 3 minutes to map these 300 square meters. In the meanwhile, in the backend, we are collecting photograms. Photograms we collect are between 300 and 1,000. And then once the activity is finished, so once you took a lot of angles of the location we are mapping, the data is uploaded to our servers. And what we do basically is using AI to actually realign these pictures, so to understand what is the angle where it was taken from. And then we extract a point cloud that is the base of the 3D map. And not only that, we also generate what is called a Gaussian splatting. So it's the representation of the 3D location that can actually be browsed in real time in normal browsers. So this content is not, only stored somewhere in our databases, but is actually accessible. So it's also a way to very fastly generate a digital twin. Something similar to what Sal was showing. In the case of what the Sal show is a different technology. It's not a Gaussian splat, but the idea is that one. In our case, we don't map specific objects, but we map locations, ambients. And yeah, so that is the process basically. And the reason why actually we started doing this activity is because we started as basically a platform to publish our content, and we very quickly understood that since we wanted to publish content that is anchored to locations, that the GPS alone was not good enough to actually publish good AR. And when we started in 2020, 2021, the technology to build this VPS was not available. And so basically we just have to do GPS. But as soon as basically we saw the first signs that we could build that, we start working on building a pipeline to actually be able to collect this data and then to use this data to relocate assets in space. So to be able to connect these 3D assets very precisely to locations. So this system is called VPS. So it's called Visual Positioning System. And to give an idea, if the GPS has an accuracy of 4 to 6 meters outdoors in clear skies, 10 to 50 meters in cities because of the buildings that they reflect the signal, no accuracy at all indoor because, of course, you have the roofs. The VPS basically can go down to centimeter precision depending on how dense is the map that you generate. So really the beginning of this started from our need to actually have a better system to publish compelling AR experiences that are connected exactly to the location that we want, but actually went well beyond that in time. And so, yeah, that's about VPS, I would say.
One last question, then I'll kick it to Connor. Is just to understand more about the use cases. Like you mentioned that VPS is became viable as you guys were building this business, and now can provide much greater precision on positioning than GPS or some other alternatives. What are people using it for? What are the first use cases that are getting traction?
Yeah, so I would say that the first use case, and that's the reason why we really went into that was it is AR, I would say. So a way to relocate assets in space. But if we try to expand this to a more general usage of this technology, at the end of the day, what this technology does, it allows devices and robots and machines to understand very precisely where they are in space. In the case of AR, of course, you have your smartphone or your smart glasses. You need to understand where it is in space to correctly project AR content. But this goes beyond that. So you can think about that also a way to allow machines to orient, to understand where they are in space. So another use case that is getting traction, and actually we are working very actively on right now, is, for example, ride-sharing companies. So ride-sharing companies, they have the problem with scooters. They need to park it correctly, otherwise they got fined by the municipality. The problem is that how you establish that you are in the right location, because the GPS will give you 50 meters errors inside the city. So the solution to that is basically switching to this VPS, where you take the stream of the camera of the device, the smartphone in this case, of course, because you have one when you take one of these scooters, and basically take the stream and understand where you are in space based on this stream. And so you can go down then to like 5 centimeters, 20 centimeters precision, again, depending on the precision of the map. So in general, VPS is much more than AR. And I think that we're going to see more and more of use cases, especially with robots coming into space. Because right now, of course, it's AR and these kind of use cases for localizing objects in space, like, for example, the scooters. But once we start having really robots that need to navigate the space around that, this use case will expand even more.
I'll pass it to Connor, but I want to show my point cloud skills. I was visiting Connor in Miami a couple months ago, and it was Art Basel, and this is this huge like elephant exhibit, and I got a pretty good one. It takes some learning though to learn how to take good images, videos.
Yeah, that's super cool. And then I want to just double click on VPS versus GPS real quick. So I think GPS is pretty widely understood as like the triangulation of a signal from a device like a phone or a car to different satellites in space, and you're able to like ascertain the location kind of on the globe or on the earth of that device from like a non-technical perspective, or like a non-technical like high level explanation. How is VPS doing the same but much more accurate with, I think, just picture inputs? Or is there something about signals and satellites too?
I will try my best. So at a simple level, basically what is about, you can think about trigonometry in some way. So you have a picture, you have another picture. So you have a database of pictures that are distributed in space. So you take a picture from another angle and you try to find the more similar in your database. And you say, okay, I see that there is a change in perspective. So this change in perspective, so it means what is the angle that is rotated, this picture, from the other one, and what is the distance in terms of how big are the features that they see compared to the other picture. So this is the very basic of the way it works. So it's about comparing the stream of your camera with your database of pictures, that this point cloud, this cloud of pictures that you have in the location. And this is the basic of that. Of course, right now, it doesn't only work like that because there is a lot of AI in that, but to find the best similar picture, but also to basically focus only on some details. As you can imagine, you map the location today, in 1 week is going to be different because some things are moved around. So you need some robust systems that understand that it doesn't only have to look to some details, but also to some other details, and to actually understand that even if something is changed, it's not that you change your position. So there is also a lot of AI behind that. Without that, of course, the relocalization will be very brittle. But anyway, coming back to your question, the basics of that is really just doing a comparison between different points of view and understanding what is the rotation and the distance between the other point of view. So that's really the way it works.
Yeah, that makes a lot of sense. Basically comparing pictures and angles. And I understand how you would need AI or some kind of human judgment to say, like, you know, if you took a picture of the street, like the cars moving is not an item that you should look at, right? But the buildings you should, because those you would assume would stay fixed.
Yeah, exactly as you said. So for example, for AI algorithms, it's very easy to understand what are pedestrians, what are cars, that classify those and so on, and just don't use that as a reference to relocate in space. And this is some of the things that the algorithms do in the backend. But yes, this is the idea.
Cool. And in the locating a scooter example in a city, if you were using VPS versus GPS, like roughly how many different pictures would you need to get a good idea? Like, are we talking like, 20 different pictures or 2 or?
No, it's a single picture. So basically, if the location has been mapped, so before the relocalization attempt, somebody mapped the location, and we have between 400 and 1,000 pictures over there. So you just take one single picture, and basically we relocate you in space based on this picture and based on the prior knowledge that we have on that space. So the catch about the VPS is really this one: is that you need to have this database Otherwise, it doesn't work, while the GPS basically works everywhere. That's why we are so focused on generating this database of 3D maps, because really those are the enabler of what in general we call spatial computing, physical AI, or machine perception. Without this data, it's basically, impossible for most of the use cases to relocate in space.
Gotcha. And then, speaking about like how you have this data already, right? Like, how does the average person get involved? I think Sal showed a couple different like images or 3D maps on various apps on his phone, but for you guys specifically, how does the average person get involved, and like what specifically are you looking to incentivize?
Yeah, so the point is that, again, there is this problem that the world is huge. And so we need to, we don't want to compete, for example, with Google or somebody that want to have the extensive map of the whole world and the whole streets in the world. Our goal is actually only to map relevant locations in the world. So the question now is how you decide what are the relevant locations in the world. So on that side, we have two signals. So one signal is the fact that I didn't mention before, but in our system to publish content, we have what we call OVR lands that are kind of spatial domains. So just like in the web, you buy a web domain like diego.com and you publish the content there. In our case, since we publish in space, we sell spatial domains and that are called OVR lands. So up to date, we sold 870,000 of these 3D maps, bought by 30,000 people. And that is a very strong signal on what are the good locations in the world, because each one of these buyers was asking itself, where is a good location to buy? Because mostly they did it as an investment. So it's a collective wisdom, I would say, on what are the good locations. Plus, we'll make this database basically with what are the points of interest that are classified on OpenStreetMap. And so together, basically, we can score what is the best locations to map. So given this data, basically we give different incentives depending on the location. So if you are in the middle of the desert, you can map it. For us, it's free to map in our app, but you're not gonna have any reward. If you map a location in New York or Miami or other locations that basically are hot, let's say, we're gonna give you a reward. And again, the reward depends on how hot is the location. So if we go to the buyer's behavior, so if, like for example, Miami, there is, Wynwood, people bought a lot in Wynwood. In Wynwood, we'll give higher rewards than, for example, just in the beach, let's say. So yeah, that's the idea. And so users basically have the map in front of them, and they can decide where to go and see what is the reward before doing the activity of mapping. And so for us, it's very important to do that at the beginning. When we started, we just let people map everywhere because just we needed to test the system. But basically from December of 2023, we started with this focused incentive model. So basically, we just want relevant maps. We don't just want maps everywhere. Because of course, at the end of the day, we need to distribute the incentives wisely, and also to use our computing resources wisely, I would say.
Yeah, what are one or two of the factors that make an overland or like a specific street or area more valuable to like end buyers and therefore to your network? Is it about like the number of people that traverse there every day, or is it about like, maybe like real estate kind of changes or updates in the area?
Well, so it's a different. There is not an explicit, way that the people choose these places, but of course, like landmarks or location with high traffic, like stations, airports, or touristic attractions, are for sure. Locations that people do buy, and actually are also places that are points of interest on OpenStreetMap and other databases. So basically, I would say everything that is high traffic, where there is a lot of human activity, usually it's a valuable location. If you check our website, also it's kind of interesting on the website, on the marketplace, you can see where people bought, and you can see that is a kind of heat map on what are the most important locations in the world in terms of where people are. Because again, at the end of the day, we want to have the maps of locations that people will visit, or that people would want to actually have some activity in.
Gotcha. And then I know you guys just did a raise recently. So talk to us about that? How much did you raise? Who was involved? And what are you excited to use those funds for in 2025?
Yeah, so that's also I need also to thank, of course, Sal to actually spearheading this. So yeah, we had a raise from of course EV3, Modular, and Lattice, and to us this is super important because I would say that we've been bootstrapped, so we don't have VCs between our stakeholders up to now since when we started back in 2020. So I think that this is really a testament on the fact that we're going in a right direction. Usually VCs get on board on really early stages and so on. So we are kind of OGs, let's say like this in the space. So it's really important, but also it's really important because of the kind of investors that we have. So we are now really focused on is this deep-in space and the fact of having investor stakeholders that basically are focused in this direction and can actually help us both in terms of networking, but also, in terms of guiding the strategy. I talk maybe even too much for Sal with him because we always, try to spar a little bit to understand if our strategy is good or not. So, it's not just about actually the finances that this investment bring to us, but also it's a way to expand in this space in the right way and investing the money in the right way. In our case, of course, the most let's say consuming activity in terms of finance is the incentivization. So this definitely help us in this direction. And also, so in this case, to actually go even faster in the generation of these 3D maps, we have a kind of a number in our head in terms of what is the number of maps that really will generate a critical mass. We think is around 250,000. Right now, the average reward that we distribute is $1.5 per location. So we can get to this number quite fast. Of course, how fast we get there depends on how much we press the pedal in the incentivization, but not only. Also in the way we distribute these incentives and the way we make the mapping activity even easier. Because right now, of course, I said it's 2 to 3 minutes. That doesn't look a lot, but you have to think that also you need to actually move in the location and go in that specific location. So if compared to other kind of businesses where deep in platforms where basically the data collection is a little bit more passive, in our case, actually, we require a quite big effort to the mappers to actually generate this data. So yeah, that's
Yeah, Diego, it's been awesome to back you guys and get to know y'all. I'm very excited for us to be investors. One thing I want to ask with relation to that is that it's rare for us. You guys, you're right. You've been around for a while. I just looked. I think you actually launched your token in 2020, right towards the end of the year. What was it like to launch a token back then? Like, how does it feel that crypto has changed since you guys have launched the Over token?
Well, yeah, it's. I would say it's totally different world. I remember that back then when we launched the token, basically ICOs were dead, and the IDOs and stuff like that was not really, widespread yet. So we really had to find the right way to launch the token. I remember back then we used this. Very interesting, actually, way to launch it was an IBCO. So it was an initial bonding cure offering that only basically us and other Gotchi did, I would say. It was kind of complex smart contract. It was an automated market maker, basically, where that issues the token and also buy back the token. So was, a nice way to launch it, gave to the community some assurances on the fact that basically there was the liquidity to buy back the token. So it was both a primary and a secondary market together. So yeah, it was really, really totally different world. But from now, I'm actually happy that this is on our back because it was really a very, very stressful and difficult event. It went quite good. I remember it was, but it also was very difficult because at the beginning, I remember in 10 minutes we raised $800,000, basically both from the IBCO, and in the subsequent 10 hours they sold them all. So basically, we went to 800,000 to zero very quickly. And then actually in January and February, the market picked up. And things went really, really good. Of course, we also were in the metaverse craze. So there was on the NFT craze. So there was a lot of winds pushing us in the right direction. But yes, it was super hard. So if I had to launch a token right now, today, I think, of course, I would not use an IBCO. Probably I would use a Launchpad or something like that. But yeah, it's always really a very, very difficult moment, and you need to find the right magic to do that.
Awesome. And then Sal, from your perspective, what was kind of the thesis behind investing in over the reality? Like, what got you excited enough to get over the hump and put some money in?
It's a combination of two things. The reason why we found it exciting and we're excited to go invest is that it's very rare to see teams that just grind through most people quit in the bear market. And, very few people grow their network by 5 or 10 times or, whatever the number of images and maps taken was over that time. And the Over community, I'd say you guys spent not a lot of effort in telling the story of Over to the broader crypto markets, but the amount of product market fit with the community and with mappers and with people using the developer platform was extremely, extremely strong. And you could see it in just all the growth metrics were up and to the right. And so that was the signal for us that, frankly, I think when we first met, it was before we understood a lot of how, I didn't know what point clouds were or what photogrammetry was, all these things I learned through the process of diligence. But we knew that obviously the users were really focused on engaging with this and on a repeat basis and creating something of value. And the more then we learned about the industry and studied what was going on, we realized that one, having a 3D map of the world for all the use cases around robotics, around AR, machines, AIs, avatars, all of these things are going to need awareness of the space around them. The way to do this is through spatial perception. I think vision is the ultimate kingmaker of sensors. And you see this in humanity. I think you'll see it in robots and machines too. And when we looked at the biggest Web 2 businesses that were doing this, both, there's scanning platforms like Scaniverse and Polycam. There's folks like Niantic that are building they have a community of people that are mapping, and they're also building developer tooling. They're just not that far ahead of Over. Over's half the size or 3/4 of the size of them when it comes to the actual valuable thing, which is the moat. And the people who were doing it best, like Niantic, were doing it in a sort of community-centric way. They just, they had this asset in Pokemon Go, whereby they're able to place a Pokemon in some location and arbitrarily get people to map it. I actually think crypto incentives are I have a lot more conviction that people 10 years from now will be willing to map things for money and tokens than I do that they'll still be playing Pokemon Go. And so I think this is just a fundamentally first principles better system for how to create a global map. And the execution was, the proof is in the pudding in terms of what we could see. And so that's what drove us. And I think also, not to speak for the modular or lattice teams, but I think the three of us think very similarly. And we were all quite impressed by the testament of how much the community had grown and how big the ambitions were to create a global 3D map.
Yeah, I mean, also this year for us is a little bit, I think, turning point also again, because, I mean, we've been evolving a lot in time, of course, from just a publishing platform to a deeping platform collecting data. But actually this year we're gonna have another big leap. Because right now our business model is based on these land sales that I was mentioning before. I mean, this is tremendous business because, as I mentioned, we sold more than 870,000 of these lands with a price between $10 and $100, depending on how hot is the location. Again, with the same logic we mentioned before. But the point is that, of course, crypto markets are very volatile. And so we can have periods where we have a huge revenues and people and bear markets, as I was mentioning before, where we don't have. So this is related with the crypto market. We cannot do nothing about that. But what we can do is actually expand our reach beyond Web3 and going to Web2. So basically what we're going to release actually will be the beginning of next month is what we call Over Business, where basically we take all the features on the platform for end-to-end publishing and browsing that we built for Web3 and make it available for Web2 companies. And so they will not have to deal with tokens, NFTs, lands, or whatever. They just will have a subscription model that basically leverages all the technology that we already built for Web3. And so this will add an additional revenue stream that is uncorrelated to crypto markets, but will be reinjected in crypto markets by giving rewards to OVR landowners and actually token buybacks and bursts and so on. So really, we believe that adding this value proposition will stabilize and actually increase the revenues that we generate, and like creating, what is called a flywheel in Deepin. So this is something that we are very excited about, and we already have a very clear vision of what can be the clients over there. So from digital marketing agencies that use our platform to enrich their value propositions for their clients, like retail clients and so on, industrial use cases, for example, for remote manutention, digital twins of plants, and so on. There is the case of ride sharing that I was mentioning before. That is also a very important one. And then finally, there is another sector that I wanted to mention that, is what we call the robotics sector. So I was mentioning a little bit before on the fact that this visual positioning system, spatial computing technology in general, right now is used for AR specifically, but will be used especially by machines in the future. And so we are really working quite hard also in this direction. And we believe that there is a great opportunity over there. So right now, everybody's quite familiar with what are called large language models. So these models that basically understand language. So we are seeing the first signs of another cohort of models that are called large geospatial models. So these models, instead of really dealing with language, they deal with the space, the understanding of the 3D space around machines. And just like LLMs need incredible amount of text to be trained, these LGMs basically are trained through 3D maps, so through the data that we are collecting. And we are convinced that we have really a unique amount of this data and also quality database of data. So what we're going to do is that this year we also going to start training our own LGM to actually deliver downstream use cases based on these models. And again, the downstream use cases, these models basically create priors on what is the structure of the word, in the same way basically LLM create priors on the language, let's say. And so the downstream stacks are multiple. One of these is again VPS. So right now, as I mentioned, to actually relocate in space, you need a database of pictures of the location you're trying to relocate in. But if you think about the way you understand where you are in space, you don't need a 3D map of a location to understand where you're in space. You actually look around and you immediately have an understanding on what is around you. If you look, for example, at the table or at a chair, you know how is the back of this chair without seeing it. Because you know how the world is structured. So these models can allow you to relocate in space very precisely, even if you don't have all the data that we have right now. So thanks to these kind of models, we can really actually expand our VPS proposition to much, much larger space. And again, also regarding what is called machine perception, the fact of having this model where machines and robots can understand the 3D structure of things without having to look around them is another very powerful use case. So, of course, this is under development. We believe that we will have it by the end of the year. It's a lot of GPUs to do that. But we really believe that not because we are incredible data scientists, but because we have an incredible database, we can really generate something very compelling over there. And this also goes in another thing that we just announced. We just announced it that, for example, we partnered with other data collectors, for example, with Niantic, that have some similar. They're going to collect some similar data, but not the same really, because the data they're collecting is more similar to the one that Google Maps have. So it's streets, so taken by cars. And so it's very complementary data. So their database is very extensive, Our is very focused and very dense in specific locations. So we can actually put together these databases also to train these models. And not only to train these models, but also to expand the reach of our VPS. If you think about that, our VPS right now only works in the location that we mapped. But actually, we can actually extend the coverage with the location that they take the videos from, they take the pictures from. And again, these LGMs are very important in this space because their data will be sparser than ours. So we need some models that have priors on the world to actually leverage that data that are a little bit sparser than ours. So yeah, this is I would say, the two main things that we are working on this year. And for us, it's paramount to actually really succeed in both of that, to really establish ourselves, to keep reinforcing on what we're building right now.
That's awesome. Will it be open source, the model that you guys are training?
Yeah, so the idea is to actually, for us, it's very important to be open source because we need to showcase that we want to have benchmarks that are higher than the ones that we see right now. So we're still trying to figure out exactly how it will work because, of course, we want to try to retain some value out of these models. So probably there will be two versions of that. So one that is open source with certain kind of precision, and one like proprietary with more precision. Or we can do some kind of model where basically we host the model and we serve it. So we are still trying to wrap our hand around that, but before we need to train it. So once we train it and we see the result, we will actually figure out also what is the final delivery of this. But for sure, we will have a part of that that will be open source because, of course, the scientific community will need to be able to actually test it and reproduce our benchmarks.
Awesome. Well, thank you very much for coming on, Diego. Super exciting what you guys are building. Where would you like to point our audience to on the internet to learn more or to get involved in your community?
Well, I mean, I would definitely just check out our website, so overthereality.ai. And I mean, X is the right place to stay up to date with all of our announcements. Just have a look to our marketplace, check our maps, see what they're building, check our AR experiences, and why not try to map and let us know. I mean, just connect with us. If you need any support, we have both Telegram and Discord. What do you prefer? Discord is more usually for technical people, both for publisher and mappers. And Telegram is more like casual. But yeah, I mean, you can go on from there.
Awesome. Well, thank you very much for coming on.
Thanks a lot.
Thanks, Diego.
Thanks.